16 again, let me know, raise your hand, yeah? And you can take it again, no problem. I'll move you over. There you go. All right, so here's number 4. Let's do number 5 because it's division. So, and we're going to be dividing by x squared minus 16 over 5x. Okay. So it looks like there's some stuff here looking at that we can factor. Okay, that's sure, we can notice that. But since this is a division, we're going to take this guy and flip him over and multiply across. And we'll do that as we go along. So let's go ahead and tackle this. Okay, the factoring for that. We have x squared, 9x, and 20. And we'll go ahead and rewrite this x plus 5. Can you tell what this will be with the 20?
10 and 10 and 1.
Well, 10 and 2 makes 20, right?
Right.
But also 4 and 5. 4
and
times
4,
5.
yeah.
Yeah?
Positive 5, positive 4.
And that will add together to be 9. Yeah? Okay, so I'll go ahead and put that. X plus 4 and x plus 5.
Where's this from? The...
This is quiz 14, a practice
This is a
quiz.
practice.
So we're just doing an example. This is the last question. So this is going to look like the last question on quiz 14 on your desk. Cool? Okay, cool. So now we're going to take this guy. Since we're dividing, this is going to end up in the denominator down here. And this is going to end up in the numerator up here.
Yeah.
So
Got
let's
that.
go ahead and do this guy first and factor this. I can pull a 5 out of both. So this is going to be x minus 4. Yeah. Okay, so that's taken care of. Let's go ahead and do this guy.
X minus 4.
Correct, yes. This is a difference of squares. So the square root of this guy is x, the square root of this guy is 4. So our standard form looks like x plus 4 times x minus 4, okay? So I basically have taken whatever I can factor and factored it and rewritten it. And this becomes a multiplication now because I flipped. And what that means is I take my line and I draw it right over. So what that is I've got an x plus 4, an x plus 5, an x minus 4, and a 5 up top. And on the bottom, an x plus 5, x plus 4, x minus 4. So I'm looking for stuff I can cancel. These ones look like cancel. Lamb, lamb. I've got an x plus 5 and an x plus 5. So I'm going to cancel those. And I've got an x plus 4 and an x plus 4. I'm going to cancel those. And the only thing that's left is a 5. That's the answer. That's it. Okay. Okay, cool. Good morning, everyone. Some of you that just came in, let me know if you'd like to retake quiz 13. That's totally cool. Raise your hand. I'll come around and drop one off. Yep. Okay, cool. I've got plenty of them. Is this a party? There you go.
Excuse me, ma'am.
Yeah.
You didn't tell me what I get wrong with my homework where you give me 3 out of 5.
Yeah. Well,
I did some of the work progress in the back here if you'd like me to say something.
Yes, you did.
Okay.
I'll tell you what, let me take it, and I'll get you after class, okay? And we'll go over it. Okay. Yeah, if anybody takes issue with what I did on your quiz or your homework, come talk to me. Let's fight about it. Okay. Cool. No, we're not gonna fight about it. I'm a reasonable person. No worries. Okay. So briefly, I'm just gonna make sure I've got a couple going here. Who's here? Susanna's here. Alex is here. Serena's here. Paulo, Gabriel, Brody. Okay, that one. And Adrian. Mari, Kevin, Tim, Zoe. Okay, cool. So let's get started on today. I will be here after class. Okay, so you've got an extra hour. If you want to talk about anything that we've done last class, this class, practice quiz, homeworks, quizzes, whatever, I'm your friend. We can go through anything you want, and we'll give you credit for it. It's all good, okay? Because I know it's a bit of a speed bump, losing your normal teacher and getting a different one. So today we're going to be working with, again, rational expressions, right? It's a big fraction with some polynomial up top and some polynomial on the bottom. Last class we did a lot of work with factoring and canceling stuff out. We also talked about opposite expressions, where A minus B is the opposite of B minus A. So if you see those two, they're real good to cancel out with each other, but instead of canceling them out to 1, they cancel out to -1, okay? And we're gonna go over that today. It's gonna make another appearance a little bit later on. So there's plenty of time to review that. Okay, so today we're going to be adding and subtracting these big fractions, all right? Yay, it's a lot of fun. We're going to be finding, the way to do that is to find the least common denominator between the two fractions, all right? So as an example, introductory, if I've got 1/3 and I want to add 1/3 to it. I've got a third, and I want to add another third. How many thirds do I have? I have 2. I have 2/3. Okay? So that's pretty intuitive, but what we see is that they have to have the same denominator in order to add them directly. And when we do, we just add the numerator together. Okay? That's how we add fractions. Good morning. Now, if I was to try and add 1/3 and 1/6, can't add that directly, okay? This is not 2/9 or 2/6. That's not how that works. What you have to do is force these to have the same denominator, okay? You have to force one of them to match the other one, okay? So if this one is a 3 and this one is a 6, we have to say, what is the least common denominator? What is the LCD for these two? What is the lowest number that both of these will divide into evenly? Okay, that happens to be 6, because 3 will divide into 6 evenly, and 6 will divide into 6 evenly. So our LCD for this guy is 6. Okay, great. What do we do with that? Well, now that we know what our LCD is, we have to force the other one.
Isn't that the greatest common denominator?
No, the greatest common denominator is blah, 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 great. It could be like 18 or 24 or 108.
Oh, I'm thinking of least common factor, aren't I?
Yeah.
Thank you, sorry.
Yep, it's all right. It's all kind of related. It's all, how are they related by multiplication? But in any case, all right, so the least common denominator, the number that is the least that both of these can divide into equally, is 6. So we have one of them that's already got a 6 down below. So we have to force the first one to have a 6 down below. We have to convert it, okay, into an equivalent that has a 6 down below. So what is 1/3 in terms of sixths?
2 6.
2. Yeah, because 2/6 reduces down to 1/3. Okay, so I know I'm using real, simple numbers here, but these very same principles will apply today. Okay, and we're gonna show you that. So now I have 2/6 and I have one more sixth. So if I add 2 and 1 sixth together, I end up with 3 sixths, yeah? Okay. So the process we used was taking both of these together and say, what is the LCD? Anything that doesn't have that complete LCD, we convert it into something that does, and then we can go ahead and add across with the common denominator on the bottom, okay? And now, after we're all said and done, we have our final answer, but we can further reduce that, okay? We can further reduce this to 1/2, because we can divide, we can factor out a 3 from the top and the bottom. So our original problem right here, which at first isn't quite obvious, when we add 1/3 and 1/6, what does that equal? Here it is. That's how we figure that out. Okay? So we're going to be applying that today when we add and subtract these rational expressions. Find the LCD, force anything that doesn't have that LCD already in the denominator into something that's an equivalent so that we can add them. And we're also going to revisit the concept of opposites, which we talked about last time. Okay, any questions on this? Okay, cool. Okay, so here is our first example of this, okay? First of all, we're gonna add together these two rational expressions. Okay, they look messy, but there they are. So you look at this stuff and you're like, well, I should start factoring this immediately. But if they have the same denominator, they're okay to add together. Same denominator means you keep that denominator on the bottom and you add together the numerator. Good? Okay, cool. Okay, so let's talk about the LCD here, okay? The LCD. Well, they both have the same denominator. So that is the LCD. Let's go ahead and factor this. Okay, it's good practice. Let's go ahead and do that. The LCD is going to be two binomials, just like we've been doing. Okay, we have a 63 down here on the bottom of the x, and we've got a 2 up here. Let's keep that negative 63. So we're going to find two factors here that when we add them together result in a positive 2. And when we multiply them, result in a negative 63. Okay, and those happen to be x plus 9 and x minus 7. Here it is down here for later. But that's our LCD, okay? So when we add these together, since they already, both of them have the same denominator, we're all good to add 1/3 and 1/3 together. So we're gonna add across, we're gonna add the numerators. The numerators will be x squared plus 6x plus 7 more x's plus 36, all right? So when we simplify that all together, we're just looking again at the denominator now. We have an x squared, 6 x's and 7 x's are 13 x's, and our one constant, 36, okay? So that's good. Now we've got something up here. This looks like, oh, another thing to factor, right? But it's okay, we can factor it. So the numerator over the common denominator, okay? And we're gonna see this again and again. So when we factor this numerator, again, we'll use our x. We've got a 36 on the bottom, positive 36 on the bottom, and a 13 on the top. So multiplied together, they make 36, and added together, they make 13. Anybody have a guess? 9 and 4, yep.
Yes.
There it is, x plus 4 times x plus 9. Okay, so again, let's just rehash. Our first step, figure out what the common denominator is. Well, they have the same denominator, so that's awesome. Let's go ahead and factor it. That is our LCD, okay? And we add together the numerators, just add across, and here is that factored. And now we have an expression, it looks like we can cancel something out. So we will. The those become 1, and this is our final answer. Any questions on this? Yep.
So, what if the denominator was not the same?
Yes, correct. We will get to that. We're gonna start with the simple stuff, and then we'll get to the hard stuff. So in this case, when the denominator is not the same, we're gonna have to force one of them to become like the other, okay? Or we're gonna have to force both of them to have a lowest common denominator. And there's a method to it, and we'll get to it. Okay, so here's a subtraction. It's very similar to this, only we gotta watch that negative sign. Seems to me like half of algebra is watching out for that negative sign, right? Yeah, so here's a negative sign, and what that means is this negative becomes positive because I like to go ahead and call it out for what it is. Just transfer that negative to that whole quantity next door, okay? The reason I do that is because I don't want to apply that minus only to that 5x. I want to apply that negative sign to that whole top quantity. That's important. All right, so again, we have the same denominator, so we can go ahead and add across. Great, we got the same. We got 3's on the bottom. Let's just add the tops. We might as well go ahead and factor this guy. We've got
5 and 10.
yeah. It will be 5 and 10. So 50 on the bottom, okay, and a 15 here. What two factors of 50? Multiply to make 50 and add to make 15. That's 5 and 10. So we're going to do x plus 5 and x plus 10. So x plus 5 times x plus 10 is just the same as x squared plus 15x plus 50. Same thing. That is our LCD. That's our lowest common denominator. Because they're both the same. They have a common denominator already. Okay, so now we're going to add across. We're going to add the numerators across. We're going to get 9x here. We get negative 5x's here. So 9x minus 5x is 4x. Okay, 4 and minus a negative 16 is 20. So we have 4x plus 20. Okay. So in order to get that, I rainbowed in this negative sign to both of those terms. And it turned that negative 16 into a positive 16. So when you see a negative sign in the middle here, good practice, so you don't forget about it, transfer it to the next door fraction. Put it up there and make that whole numerator a negative. Okay, that way you don't lose it later. Get that one wrong. So here we are with our LCD. We could rewrite it here if you want. We could rewrite it, but let's just go ahead and write LCD. We can rewrite it later. We've got 4x plus 20. Is that something that we can factor some more?
Yes.
Yes, it is. Okay, let's go ahead and factor him. That's what's up top, bless you. And on the bottom, we have our LCD, which is x plus 5 and x plus 10 here, okay? So looks like we can cancel a couple of things there out to 1. And we got left over 4 divided by x plus 10, okay? This x plus 5 goes away with that one. Okay? Questions? We doing good? Are we doing well? I'm not one for getting that right. People ask me how I'm doing, I say I'm doing good. How are you doing? Oh, I'm doing well. I always feel so bad about that. Ooh, I got that one wrong, didn't I? Not so good in English. Okay, so here we go. These ones have denominators that are not the same, okay? But luckily, they look very similar, and in fact, these are opposites of each other. Okay, so just like we went over a minute ago, if you have something that's a minus b, in this case w minus 4, its opposite is 4 minus w. And that means that this is minus 1 times that. Okay, so So I'm gonna go ahead and write that here. Does that make sense? I go ahead and reverse that. Now I have a minus W minus 4 over there.
How did you do that?
Yeah, well, I'll tell you what, this W minus 4 equals a negative, how do I pull that out? Hold on a second. I'll just say this. How are these two related to each other? Okay? A minus B and B minus A. They are opposites. So what that means is this, its opposite is this, okay? In this case, W minus 4, its opposite is 4 minus W,
Okay.
okay? So if I take an opposite and divide it by its opposite, I get negative 1. That's a cool property. But it also means that I can factor out a negative 1. Okay, if I factor out a negative 1 from 4 minus W, I will get a negative minus 4 plus W. Okay, or I will get a negative W minus 4. Come on, pen. What are we doing here, buddy? Slow
Pulling it out of it.
it down. Sorry, that looks a little chewed up. But so yeah, what I've done here is I factored out a negative, okay? And when I do that, I have negative 4 plus W, which is the same as negative W minus 4, okay? This 4 minus W is the same as negative W minus 4. So what I'm trying to do when I'm doing this is force them to be the same. Force them to both be the same so I can add a cross. And right now they're related, but they're not the same. And this is how I force them to look the same. Okay. Now, at this stage, they're not the same entirely. I still have this negative down here, which is gross, and I still can't add these. So I have a couple of options. I can transfer that negative to be right here, okay? Transfer him, and he can go in the middle. Or I can put that negative up top, which is what my preference is, my personal preference, okay? So what happened is we took the negative of this, we pulled out that negative, we put him up top, and now our denominators are the same. It's a clever trick. Yeah.
We're just allowed to like move the negatives to the numerator?
Yeah. Because if you think about it, minus, oh my goodness, this pen, tell you what, let's do another one. Minus 1/4, okay, that's an example. It's the same as minus 1 divided by 4, and it's the same as 1 divided by negative 4. So that negative can move. As long as it doesn't disappear, it can move. So that's what happened here, is we had a negative in the bottom, and we put them up top, so that we can now add these two expressions together. Okay? Everybody see what happened there? We look at these and we're like, how can we force them to be identical? And we use the fact that this one is a negative of this. We pull out the negative, and we move it up top. And now we can add them. Okay, so our LCD is W minus 4 after everything. Okay, and you see that's what's going to end up in the denominator. So when we add the numerators together, now that these are the same, we can add our numerator. And so we're going to add those together. We're going to get W squared minus 3W minus 4. Okay. Yep, and that looks like another quadratic that we need to factor. And here it is factor, W minus 4, W plus 1. And we see that W minus 4 repeating itself. and that goes away. And so our answer is W plus 1. Okay, cool. So we've seen what happens if the denominators are the same. You just add across, okay? If this is a negative sign in here, then you move it up top, fine. And if they're opposites, yep, question?
So wait, how does it work adding W minus 4 to W minus 4?
How does this work? Okay, good. So what we're doing is we're not adding W minus 4 to W minus 4. We're adding two rational expressions that have the same denominator. So instead of adding the denominators together, instead of adding 3 and 3, we keep the denominator the same. It's the common denominator.
Oh.
And in fact, what we're actually adding is just the top, just the numerator.
Okay.
So we keep that W minus 4 as it is. We leave it there, and we only add the tops together.
That was a good time for that reminder.
Yeah. Good question. Okay. All right. Moving along. Okay, so here we go. We've got two expressions. This first one, comma, that second one. And you're going to see this in your homework, okay, that you'll have, where they're asking what is the LCD for these two. It'll have one and it'll have the other with a comma in the middle. And you're going to find the LCD for each of those combined together, but you don't have to add them. You don't have to subtract them. It's just the first step, identifying the LCD for those two. Okay. So at first glance, they don't look like they have anything in common. But when we factor those two, we'll see that they have something in common, and we can use that. So I'm going to go ahead and factor this first one, this x squared plus 5x plus 6. Okay, so for this particular problem, we're not looking at the numerator, the top. We're just trying to figure out how are these bottom related. What is the lowest common denominator for these two denominators that we're given? So the first one here, it factors, we do our x, we have a 6 here, we have a 5 here.
6 minus 1. No. Negative 6. Negative 1.
Okay, here's some grumbling. The answers are a 3 and a 2, a positive 3 and a positive 2. Okay, so that's our factors for this guy. For the second expression, x squared minus 4x minus 21, I'm going to factor that guy, and he's going to have a negative 21 down here and a negative 4 here. Okay. Really the only useful factors for 21 that I know of are 3 and 7. And those just happen to have a difference of 4, so I'm going to go ahead and do that. Negative 7 and positive 3, because negative 7, positive 3 equals negative 4. So those are our factors here. It's pretty rare that you'll see a 21 factored into 1 and 21. Maybe you'll see it sometime, but 3 and 7 are the 21s. Okay. Okay, so here are our factored denominators. After we've been through this whole side math, let's get back to our problem. Find the LCD. Okay, so the LCD, if you remember, we just went over this a bit ago. It is the lowest common number that both of these denominators will divide into evenly. So they don't look like they're going to divide into anything evenly, but we can see that they have an x plus 3 in common. Okay, that's something. We know that this one has an x plus 2, the first one's got an x plus 2, and the second one has an x minus 7. In order for them to be the same, have a lowest common denominator, we have to choose one of each of all of those factors. And what do I mean by that? It means our lowest common denominator will have an x plus 2, it will have an x plus 3, and it will also have an x minus 7. So you take your denominators, you find all their factors, and for your lowest common denominator, you pick one of each of those factors. They happen to share that x plus 3, so we only need one of those. But you'll pick an x plus 2, you'll pick an x plus 3, and last you'll pick that x minus 7. So that is your LCD. You pick one of each from all your denominators, and multiplied together is your LCD. Okay? And so this is a little kind of mind-bending, and we're gonna get more practice at it. If I come back and revisit the definition of LCD, this denominator, x plus 2 and x plus 3, will divide into this evenly, okay? How many times does x plus 2 times x plus 3 divide into this evenly? If we're going back to our definition, well, the answer is x minus 7 times. Which doesn't make a whole lot of sense when you say it out loud, but that's what the math means. It means that this x plus 3 times x minus 7 will divide into our LCD evenly, okay? Both of these will divide into our LCD evenly, okay? So again, I know this is a little complex, mind-bending to wrap your mind around, but the process is the same.
I'm confused because they're being labeled as the LCD down there.
Yes,
The LCD will divide into the LCD evenly. That's what I'm not wrapping my head around.
okay? Okay, no worries, we're gonna do a lot of examples of this, so let me just rehash it. The question is, find the LCD between this guy and this guy, okay? So that we can add them together. In other words, force both of those denominators to be the same so that we can add them together eventually, okay? What is that thing that we have to force them to be the same? In order to figure that out and to describe that thing that we force them to be, the LCD, that's the denominator that we're after, we have to pluck one of each of the factors from the whole list. So, if our list of factors for all the things that we're working with consists of x plus 2, there's an x plus 3, there's another x plus 3, we already got that one, and an x minus 7. That's all the factors listed out for these two expressions in the denominator. We're just looking at the denominator. So our lowest common denominator is this one times this one times this one. Okay. So that's the method, okay? I know it's a little bit what, but we're gonna use this method again and again, and you'll be able to wrap your head around it. Let's have some practice. Find the LCD of this one and that one. All right, so we got an and here, it could be a comma, whatever, but we're looking for what is the lowest common denominator of this one and that one combined together. What do they have in common? We need to force them to be the same. Okay.
36 or 6?
Well, so first things first, we're not concerned with the numerator at all, okay?
No.
This question is just asking what is the denominator, so that's important, okay?
And I had it mixed with factoring earlier. The least common factor must be 36, right?
Not quite, but hang in there, all right? So on our last sheet, what we did was we factored the first one, and then we factored the second one, and we made a list of all those factors, and we take one of each, okay? So our factors for this first one are x and x minus 6, because we can factor out an x from that. And this guy, we have another x minus 6 and another x minus 6, okay? We've got to take two x minus 6s, because here's two of them. We need them. So we've got an x minus 6, and a square.
Excuse me.
So our LCD is an x, yes, and it could be an x minus 6, but we can't because there's two of them here. So we have to take the highest power, okay? We have to use two whole x minus 6s. And why is that? Well, if we called our LCD x times x minus 6 and just picked one of them, this wouldn't divide into it evenly. Okay, so I'm thinking there would be an x minus 6 left over. you've gotta take the highest power for every factor. So our factors consist of x and x minus 6 from our first one. And from our second one, we have an x minus 6 times an x minus 6. So that's my list of factors. So this one happens to fall into this. This is awesome. I don't have to do 3 of them together, but I do have to do 2 x minus 6's. So I got this guy. This second one is covered in here. So that's my LCD. 2 of them, x and 2 x minus 6's, okay? So we're not performing any operations on these yet. We're not adding, subtracting, multiplying, blah, 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 none of that. We're just looking for what is that lowest common denominator. The step after we find the lowest common denominator is forcing both of them to be equivalent to what they originally are. Stay true to themselves, but have that common denominator. And we'll get to that in a second. Okay, so here is our lowest common denominator. We take the first expression, we factor it, the second expression, factor it, and make sure that our lowest common denominator can handle both of them. This one, we can divide an x and an x minus 6 in there. We'll have an x minus 6 left over evenly. This guy will divide into our LCD, and we'll have an x left over, divides evenly. Okay. So that's the rule. Use the highest power that is shown of each of the factors. Cool. Any questions on this? All right. Let's carry on. Okay, so again, we're looking for, here's a comma, there's another comma over there, so we're not performing any operations on these, we're just looking for what is the lowest common denominator, okay? So here we have a number, we have a constant, we have some x's, and we have some y's, okay? And over here we've got numbers, a couple of constants, and we have some expressions, x minus 3's to deal with. So, if we were taking, let's take the first one. Our lowest common denominator is going to have a number in it, it's going to have some x's in it, and it's going to have some y's in it. Because they need to divide into it evenly, and both of them have all of those. So we're going to need that many, okay? So for our constants, we have a 6 and an 8. Can anybody guess what the lowest common denominator between 6 and 8? What is that lowest common factor that they have in common?
24.
24, okay? So how would you find that? Well, what I would do is say 6 and 8. Does 6 go into 8 evenly? No, it doesn't, okay? Well, let's double it. How about 12? Does 12 go into 8 evenly? 12 and 8, do they do? No, they don't. They're not the same. All right, let's double it again, 24. There you go. They both go into 24 evenly. Okay, so I just creep up on multiples of 6. I do 6, go into 8 evenly? No. 12? No. 18? 8 and 18? No. 24? Yep. That's the lowest one. Okay. Another way is you can take those two numbers and multiply them together. Okay, you get 48. They will divide into 48 evenly, but it's not the lowest one. So in order to find the lowest one, I like to take my lowest of the number and say 1 of them, no, 2 of them, no, 3 of them, no, 4 of them. Yeah, 4 of them works, however many of them it takes. So their common denominator here, their constant on the bottom is 24. Let's take the x's, okay? I got 2 x's here, and I got 3 x's here. Well, if you remember from the last slide, we're going to take the highest power of the x's, and that would be 3 of them, okay? So that would be 3 x's is our, we're working on our LCD, we're chewing away at it. Lastly, we have y's. How many y's are going to be in our LCD? 2. And why is that? Because I've got 1 here, but I have 2 here. I got to take that highest power, okay? That's 2 of them. Oh boy, we're getting into this again. Okay, that's my LCD between the 2 of these. that one comma that one. 24x cubed y squared. Good. It's like voting. Okay? All right, how about this one? Least common denominator between these two. About 6 and 9. That's a good one. 6 go into 9 evenly? No. About 12? No. 18? Yeah? If I add 6 and 6 and 6, I get 18. 18 works. All right, good. So that's my constant. I've got 2 x minus 3's over here on the left, and I've got 1 x minus 3 on the right. So how many x minus 3's do I need in my LCD? 2. I gotta take the highest number of them, the highest power, and that's 2 of them. That's it. Bless you.
Thank you.
We see it? Yep. Here we are. Okay? Cool. So in all this stuff that we've been doing, that's step 1. You gotta identify what that is. Okay? Then there'll be some adding or subtracting, some factoring, some canceling, the same noise that we've been doing this whole time. Okay? Are there questions on this? Okay? All right. Okay, so we're gonna now perform operations on these. We've got one over here and a second one over here. We're adding them together. We look at their denominators, and are they the same? Yes. Yes, they are. They're both a 5. So when they're both the same, we're already to the end of this. We just got to add the numerators together and put it over that common denominator. So once again, our common denominator is 5, and that stays just the same. And we add the tops together. 2x plus x plus 1. Okay? 3x is plus 1. Down here, only thing different is a negative in the middle. Don't forget about that negative in the middle. Okay? What I like to do is take it, make it positive, transfer it up to the top. So then it always looks the same. We're always adding. So since the denominators are the same, 2x, we're just going to go ahead and add across our numerators. We have x squared plus 1 minus 1, leaving us with just x squared, right? X squared over 2x.
Oh, right.
Anything to do with that, guys? Anything that we can cancel out?
X.
Yeah, good. X. Yeah. So that's our final answer. We're going to cancel out an x from the top and from the bottom. Okay, so we're seeing how this goes. Okay, let's take a look at the denominators down here. We already have them the same. Awesome. So we can just go ahead and add. Let's go ahead and throw that negative sign up top. Put it around that whole quantity. So now we can just add across. Okay, we're going to land that 6 on the bottom. Stays the same. And we're going to add these two together. We have 3 x's here, minus 2 x's, leaving us with just 1 x, right? 3x minus 2x. We've got a 2 and a minus a negative 1, which is 2 plus 1 over that 6. Okay? Questions on this? See what happened to that negative? We applied it to that whole quantity, and that's important. Okay? All right, those are the easy ones. What happens if they're not the same? Okay? Now we gotta come up with something. We gotta force these to be the same. So here is the heart of the matter, okay? This is the technique of today. We have these two, and we're gonna add them together, and they're not the same denominator. So the first step is to find that LCD. And remember, we take one of each across, using that highest power if we need to. But the two factors of this expression in the denominator are x plus 4 and x plus 5. Okay, we did that one a little bit earlier. Okay? Okay, good. And the second one that we're adding together, we have x squared plus 6x plus 8. We're gonna go ahead and factor that guy into this. X plus 2 becomes x plus 4. Alright. And so our lowest common denominator is going to be, we're picking one from each. Looks like they have one in common. They've got that x plus 4 in common. So we're gonna pick that x plus 4, we're gonna pick that x plus 5, and we're gonna pick that x plus 2. And that is our LCD. Does that go away? There we go. Got these pink boxes. They're little magical boxes. Okay. Are there any questions about how this happened? This LCD. We took all the factors from our two expressions and we chose one of each. Okay, now what do we do with that? In order to add these two together, we have to force both of those denominators to be this. And how do we do that? Okay, we have to transform them into equivalent expressions. That's a mouthful. In other words, what we're gonna do is take each one of them and multiply them by a special variety of 1. Okay, they're gonna be the same, we're gonna multiply them by 1, but that one is special in that it will convert them to have the same denominator. Okay, so what do I mean by that? What the heck are you even talking about? So let's take this first one for example, okay? The first one, how are we gonna force it to have these 3 in the bottom? Well, it's already got an x plus 4, it's already got an x plus 5. What it needs is that x plus 2. It doesn't have that x plus 2 yet, okay? I'm only looking at this one, okay? I'm only looking at the first one. We're missing that x plus 2 in here. So what I'm gonna do is take that x plus 2 and I'm gonna multiply it times x plus 6. And you'll see why, okay? So first of all, we're gonna take x plus 6 and multiply it times whatever it's missing. It's missing that x plus 2. So I'm gonna scooch it in here and write it out, okay? X plus 6, this is the numerator for our first expression. X plus 6 is already there. In order to force that LCD on the bottom, it needs that x plus 2. So I'm gonna multiply the numerator by what it needs, okay? It needs that x plus 2. And it becomes this. When I FOIL this out, it becomes this. I know this is kind of that's a lot for this one step. Go ahead.
How do you know, like, which one of those to use, like that?
Yeah, which one it needs. Yeah. Okay. Well, let me get back here. And let me take this guy here. And then put this guy here. Okay. So we started off with x plus 6. I'm just looking at this first fraction, this first expression. And we know that on the bottom it has an x plus 4 and it has an x plus 5. But it does not have an x plus 2 yet. So I take that x plus 2 and I multiply it times the top and I put it here, okay? Okay. So for the second one, it doesn't have an x plus 5. It's got already an x plus 2 and an x plus 4. From our LCD, it's missing that x plus 5. So now I take that x plus 5 and I multiply it times the numerator. I multiply it times the one that it needs, okay? So I'm going to take that 4x plus 20 and put it here. What happens is that they have now an LCD on the bottom and we're adding the numerators. So now this is kind of a cluster and it's okay, we're going to untangle it and we're going to have lots of practice, okay? So again, the steps of this are to find the LCD between them. We make a list of all the factors and choose one of each for the LCD all strung together. Once we have an LCD, we can then add the denominators, but we have to convert each one of those so that we can add. And the conversion is, look at what each one of those fractions needs. Which one is it missing? Or what 2 is it missing from the LCD? And multiply the numerator times that thing that it's missing, and then we can add them together safely and put it all over the LCD. Okay? So this whole mess that we did is identical to this. We took this 1/3 and we converted it into 6 so that we could add them across. That's what we're doing with this. Okay, we're gonna do a few more, so bear with me. Once we multiplied in what we're missing from each one of those fractions, we add them across. We're gonna combine our like terms. X squared, looks like we got 12. Let me get rid of this so it's a little more clear. Okay, we've got 12 x's altogether, and 12 plus 20 is 32. So she's writing this LCD, but what she means when she writes this LCD is these three, okay? Oh, that's awesome. Let's get back to where we were. Okay, cool. Okay, so again, we've added our numerators together, and it's over the LCD. This is the LCD. We've called it out, put a big red box around it. Okay, so now, once we added our numerators together, looks like a thing that we can factor, because everybody loves factoring by now. This is what it factors into. If we take our x, we've got a 32 on the bottom and a 12 up top. What multiplied together is 32 and added is 12, an x plus 4 and an x plus 8. So, we finally have one cohesive thing, all right? We finally have added these together. We have our LCD on the bottom. Our LCD consists of one of each from our factors of 4, an x plus 5, and an x plus 2. That hasn't changed. We added together our numerators. We factored our numerator. Now we can start canceling stuff out. And we're left with an x plus 8 up top, an x plus 5, and an x plus 2 on the bottom. So that's a problem for you, right? There it is. But that's the big kahuna from today, okay? That's what there is to know. Is we take things that have different denominators and we force them to have the same denominator so that we can add them over that same denominator. And if we can cancel things out, we do. Okay. So we're gonna get practice of this. Here's another one. This one has a negative in the middle, aka subtraction. All right. What I like to do is take that negative. Don't forget about it. If I see it, I move it right away so it's visible. I'm not going to lose track of it. Put that negative. We do the same steps. Since these denominators are different, we got to find the lowest common denominator so that we can add them. When we add them together, the answer goes over that LCD. Okay, so let's figure out what our LCD is. We factor this first one. We factor that second one. They're already done. I know it's not as quick as that, but it's written there. So we'll skip the side work on there. These are factored. Looks like they've got an x plus 3 in common. Okay, do they have anything else in common?
No.
No, that's it. So when we're making our LCD, I'm just gonna write all of our factors. We got an x plus 3, we got an x plus 5, and we got an x plus 4. And I just pick one of each. Pick. That's our LCD, all lined up together. Okay? So when we add these two expressions, we're gonna have the LCD in the bottom, just like we had the 6's in the bottom here. Okay, we're gonna keep that LCD, and we're just gonna add the top. So in order to convert each one of these into something that we can add together, we need to take a look and say, what's missing, okay? What's missing from here, from our list, from our LCD? X plus 4, right? That's what's missing. So we're gonna take that x plus 4 and we're gonna multiply it right here on our first fraction there, our first rational expression, okay? So we have a 7x plus 28 for the first part, okay? Then for the second one, what are we missing from our LCD? What are we missing here? X plus 5, I heard somebody say it. We see that? We've got an x plus 3, check. We don't have an x plus 5, but we do have that x plus 4. So we need to take that x plus 5 and multiply it right up here. Once we multiply those, then we can add together our numerators. Okay, so we'll have 7x plus 28 I don't know that she wrote all this out. Yep, she did. Okay, 7x plus 28. Okay, we rainbow that in. We've got a minus 4x and a plus 20, because that minus and that minus. That's what, yep.
So is there a reason why it's negative 20 down there instead of positive?
Oh, my bad.
That
This is an x
seems
plus
like it
5.
should be,
This is an x plus 5.
that's -4.
Oh, there it is. So negative 4 and minus 20. Okay, good catch, good catch.
Oh, got it. See.
Yeah? Okay, cool, cool, cool. Okay, so our LCD, check, we figured that out. The second one is convert each one into something that we can add together. Okay, so what's happening when I do that, all right? What is this whole, like, what's the reasoning behind that? Well, actually, what's happening, I'm gonna write it on the sideboard here. I've got a 7, I'm gonna rewrite my first expression. I've got a 7 up top, and I've got x plus 3 and x plus 5 on the bottom. And I know my LCD is all 3 of those, all right? And I know that it's missing that x plus 4, all right? In order to force this guy to look like, what am I gonna do? I'm gonna force him to look like something with that LCD in the bottom. This is what I want. I want it to look like something like this. What does the top have to look like? Well, it has to look like x plus 4 up top. And the reason is because I multiplied this whole equivalent expression. I multiplied this thing times 1. And that special, I mentioned it before, that special variety of 1 that I'm multiplying it for by is this, x plus 4 over x plus 4. That is 1. If I multiply this times this, I'll get the LCD on the bottom, but I gotta put that missing quantity, the x plus 4 up top. That's sort of the middle part that we skipped over with our method, but that's what's happening.
That looks a lot simpler.
It does? Yeah, okay, okay. Yeah. So I have this, I need to force the bottom to look like this. What do I multiply the top by so that I can make the bottom look like this? I can't change the value of it, that's not allowed. So I have to multiply it by a value of 1, and the value of 1 is in this format. That's what that means, okay? So, but long story short, too long don't read. What I do is look for what's missing and multiply the numerator times that thing. And that's what's going on here. So once both of them have the LCD, aka multiply the numerator times what's missing, then I can add the numerators together and it ends up over the LCD. Okay, here's added, there's nothing to cancel out, so my answer has the whole full LCD in there with nothing canceled out. I'm happy to go over that again too if y'all need, that's cool. But this is the method that you're going to use. You can write it all out using that multiplied by 1 in that special form. Okay. All right, let's keep going and we'll see where we end up. First of all, there may still be questions on that guy, and that's fine. Are there any questions on this method that I used? Find the LCD first, selecting one of each of the factors, okay? And then look at each one and see what it's missing and multiply the numerator by that thing that it's missing. Okay, that's our method. Okay, I'm not seeing anybody that's upset at this, so we're gonna keep going. Okay, here we have 3 expressions, yay. 3, because that's exactly what we need. All right, we've got a subtraction in here. All right, I see that, and right away, I just put that negative up there. So I want to lose it. We've got a thing to factor, another thing to factor, and another thing to factor. Okay. Thankfully, your teacher has factored these already. They're pre-factored. Awesome. Okay. So these 3 expressions here, plus this, plus that, they're rewritten over there. But these ones just have factors. Okay, so our whole list together, we have an x minus 2, an x plus 2, we have an x minus 2, check, we have an x minus 1, we have an x plus 2, got it, and we have an x minus 1, got it. So our LCD is kind of one of each, right? Multiplied together. Okay. I'm seeing the squinty eyes of I don't get it. Raise your hand if you don't get it. It's cool, I can go over it some more. All right, fair enough. Okay, so we've got our LCD, and going back to our method, we take each one of these and say, what is it missing? And, come on, babe. All right, well, we'll move you away. What is it missing? We multiply each one of those by whatever it's missing, and then we put that numerator over our LCD. Okay, so we'll go through this one by one. First of all, there's that dang negative sign. Let's put him up top. This first one is an x minus 2 and an x plus 2. What is it missing?
X plus 1.
X minus 1, right? We've got an x minus 2 and x plus 2 is missing that x minus 1. So we're going to take an x minus 1 and we're going to multiply it times that first numerator. The second one, we've got an x minus 2 and an x minus 1. Check, check. What's it missing?
X plus 2.
X plus 2. Okay, cool. Here's one to use for us. Okay. And the third one, which one is it missing?
X minus 8.
Okay. Alrighty. So that's our method. Now what we're doing in reality here is we're multiplying it times a special variety of 1 that forces each one to have the
I just
same
undid it, didn't I, guess?
denominator. Pardon?
I hate when I just undo an operation. I guessed ahead and I,
Oh, okay, alright. I can speed up if you want.
no.
Okay, cool. So here's our LCD. Any questions on how that happened? Any questions on what we're going to multiply by in order to force these to look like the same denominator? We look at what's missing, okay? When we do all of this, we multiply out. We have 2x squared minus 2x. We have minus x minus 2, x plus 1 times x minus 2, which is this stuff in green right here, okay? Fill that in. So we're going to combine like terms here, LCD abbreviation, but it's that, okay? It's that. LCD is this. What do we have here? Oh, that's my box from over there. Okay, cool. So we're going to combine like terms, and we end up with 3x squareds. How many x's? We have minus 2, minus 3, minus 4 x's. And how many of our numbers? Minus 2 and minus 2 more makes minus 4. Okay. Looks like we can factor that. Cool. If that's my phone pinging, I'm real sorry about that. I'll quit it in a second. 3x squared minus 4x minus 4 factors minus 12 and a minus 4. Okay, factors into this. 3x plus 2, x minus 2. There's nothing to cancel out, and that's okay. You're going to see that. You're going to see that on occasion, on your homework, on your quiz, whatever. You're going to be like, there's nothing to cancel. That's okay. It doesn't mean it's wrong. It just means there's nothing in common from the top to the bottom. So this is our big, ugly answer. But there it is.
Cancel.
Pardon?
You can cancel that x minus 2.
Yeah, you can. Yeah, I knew that. I was just testing you all. What's up? Thank you.
Your green part at the end.
Yes.
The last thing that you distributed, it looks like you distributed the x into the parentheses as well.
This is my green.
And
This.
that is your green.
Yeah. So I just did FOIL on that. I've got a quantity of x plus 1 times a quantity x
Two
minus
parentheses,
2.
that makes sense
Yes.
to me.
Yes.
With one parentheses, that's why my answer was different, because I was doing 1 times x minus 2 plus x.
Okay, yep. Parentheses, yeah. When we're doing this, consider there's always a hidden parentheses there. If you're gonna operate, do anything to it, multiply, divide, whatever, always safety, put in those parentheses. Assume they're there every time.
Why? That doesn't usually happen in regular algebra. Is it because it's a numerator for some reason?
No, it doesn't have to do with that it's in the numerator per se, but if we're looking at this thing on its own.
Oh, got it. Now I see it. Sorry.
We're
Thank
good.
you.
Okay, cool. There it is, okay.
We're multiplying both those terms, so now it has parentheses.
Uh-huh.
Sorry, everybody.
Cool. Any questions on this? And it's a little convoluted. Okay. Thank you, Angel, and back. X plus 2 and x minus 1. Here's a bonus question. Does this thing right here, before I cancel anything out, does that equal that? Is that the same thing? Like, which one could you put on your quiz or your homework? Yeah, they're equal to each other. Okay, they're not, this isn't wrong per se, but you can still reduce it further. But they are equivalent to each other. Like if I were to pick a magical number for x, like 1 or 2 or whatever, and plug it in, I get the same answer right here, evaluated to the same as that. They're equivalent. Okay, let's see. Here is another example, and I believe this is the last of it, and we've made it through. Congratulations. Let's do this one last thing, okay? So here's a negative sign. I don't like it. My first instinct is to throw it up top, so I do that, okay? Let's factor this denominator. What is x squared minus 49? Anybody? We have one in the back.
X plus 7, x minus 7.
X plus 7, x minus 7. We see it? Okay, this is a difference of squares. Cool. All right, let's factor the next one. Anybody see that one? That's also a special form.
X minus 7, x minus 7.
Yes, yeah. So this is special form because that 49 is a squared number. This x squared is a squared number. The square root of this is x. The square root of that is 7. Since this is a negative sign, they're both negative. 2 times 7 times x does equal 14, so this works out. In other words, if you check it, you'll find that x minus 7 times x minus 7 is that. All right, so this is our list of available factors to make our LCD, okay? So let's build our LCD out. We need 1 x minus 7, cool. We need an x plus 7. And here we have 2 x minus 7s. So we gotta use 2, okay? Gotta use our highest power. If we don't, that won't divide into it evenly. So here's our list of stuff for our LCD. Meaning, our LCD, let's use a different color, equals x minus 7. Why? All right. We'll go back to blue for goodness sake. X minus 7, 2 of them, and x plus 7. That's our LCD. Just ignore the green. The green isn't happy today. Doesn't work. But that's our LCD. Okay? Yay. And that LCD is what's going to end up on the bottom once we add these together. All right? So let's take a look at this first guy. X squared minus 49. It factored into this. So from our LCD, from our big list, what is this one missing?
1 x minus 7.
Yeah. So we have available to us 2 x minus 7s and 1 x plus 7. We only have 1 x minus 7 here. So it needs the second one. Okay? So that's what we're going to multiply this top. X minus 7. Okay? And this guy here, we have 2 x minus 7s. So what's it missing from our LCD?
X plus 7.
It's missing that x plus 7. Yeah. So we're going to multiply
said yes to the prank call today.
Okay,
Barry, that was you.
okay. So once we do that, we're gonna be converting these into have the same denominator. So let's go ahead and do this. I'm gonna use the abbreviation LCD and just know that it's that. Okay, I can rewrite that, but let's do this for now because it's an intermediate step.
Is that day 15?
I have 3x's and minus 21. 3x minus 21. And I have minus 9x minus 63.
Let's see what we had last. 14 was last, that's the right one. That's right.
All right. So let's combine like terms. I have minus 6x minus, what is that, 104? No, 84. Minus 84. Over our LCD. I think I did this one already, just to make sure that I didn't F it up. No, I didn't. Okay. Over, I'm gonna go ahead and write as well. Our LCD. Okay, does anybody have any questions about how we got here? Okay, we looked at each one, what does it need, multiply it across. We're combining our like terms. Looks like we can factor out -6.
14.
Thank you. Okay, is that it? We good here? Yeah, that's it. We can't do anything else. We have factored this completely. There's nothing in common on the bottom and top to cancel out. This is our noisy answer, and there it is. All right, so to recap, first things first, find that LCD. Some of your questions will be, what is the LCD? And that's it. You don't have to do anything with those expressions. Once we figure out what our LCD is, look at what's missing from each term, multiply it, and then we can add them together over the total LCD. Combine our like terms, do any factoring if we need to, cancel stuff out if there's anything to cancel, and that's your answer. The other thing that we touched on today again was the opposite, okay? So if you see something like W minus 4, remember this, over here, and a 4 minus W, those look real similar. What you can do is say the LCD is W minus 4. Yes, it is. But on that side, you've got to take this, convert it, and have your -1. Remember when we did that? So both sides will be W minus 4 and W minus 4. And the -1 that you pulled out of that second one is going to go up top. So you can do your operation between. All right, so for the practice quiz for this guy, I'm going to be here doing that. We can talk about that. If you have questions on homework that's due today, here's the list of what's due today. Okay, I'm here to talk about that. You can do that all day long. If you'd like to retake quiz 13, no problem, you can redo that. And quiz 14, which is from last class, will be due at the end of today. All these are due at the end of today. But if you have questions, I'm a happy, friendly person, and we can talk about all of it. So before you have to turn anything in, I want you to be comfortable with what you did. Okay, and we can walk through it. All right, so I know we finished a little bit early today. On your quiz, if you're not quite done with it, you guys can work in groups, work in pairs, as long as you show all of your work in your own handwriting on your paper, then you can turn it in. So you can go ahead and work together.
What, quiz 13?
Pardon?
Or quiz 13?
For quiz 14.
Quiz 14?
From today, yeah. Yeah. Yeah, you can. Thank you. Uh-huh. And thank you for your time. Hope I got everybody that was, I think everybody was here today.
This is a square root, right? This is x plus 2x minus 2. And this one is, minus 8.
Alright, okay, so Vista wasn't here.
I'm burnt, I need a minute.
Oh, okay, so, okay, let's go over
Should be
this.
able to, everything should cancel out each other, and should just have 4 on the top.
And 15, awesome. 5, 10, 12, 13, 14, 15. That's so weird.
Yeah, are you? Yeah, I'll be there. Yeah, I'll be there. Are there?
Hey, mine is good.
All right, no problem. I'm ready for it. I'm ready for it.
I don't know what to say.
Okay.
I don't know what to say that other than I must have just not seen this work.
Right.
But it'll be a 5, and
Okay.
I apologize.
It's all right. It's all right. Let's go.
I've never done that before,
It's
but
okay.
there it is.
Thank you.
I'll only give you a partial if you didn't do all the work,
Okay.
but you totally did, so I'll change it. Sorry about that. That is gonna bug me. Okay, cool. Yeah, hi. Number 1, yep. Let me pull it up on the board. So for number 1, it's only looking at the denominator. It's saying for what values is this undefined? We go back to the definition of undefined, it means the bottom is 0. You can't divide by 0. So we want to know what z is going to make that bottom 0. Okay. That's the definition for undefined. So for this, it doesn't matter what's up top. That 9z squared, doesn't matter. Okay, so what we can't have is the bottom being 0. What value? So we're gonna set that bottom equals to 0. That's the only interesting case, that's only what we're looking for. Because if this is 0, it's not allowed, it's undefined. 0, and that's what we're looking for, and what makes it undefined. So we're just gonna solve for z. So we have 8z equals -5, and z equals minus 5/8. So we could have anything up here, it doesn't matter, but this is what we want to set equal to 0. Okay, cool. Yep. Yep, oh, thumbs up, okay. Okay. Tim, you good?
No,
Not good. You're not
haven't
good.
even formed a question.
Yeah, what question?
I don't know.
Okay.
So
Well-
my catchphrase is best question to ask is what question to ask. And I worked on that phrase for a while. However, there's still a flaw in it because sometimes I don't get a question when I need to ask something.
Okay.
They say there are no stupid questions, but
All right, well, I'll tell you what, go through your stuff, and when you find something that you don't understand, I'll help
here's a
you.
question.
Yes.
I'm going in the right direction if I put that on the other side of the equals and then try to make a factor for those.
Okay,
So
so
the
find
x
all
squared.
values that make this undefined. So first of all, look at the question that's
Yes, I
asking.
want that to equal 0.
Yeah, good.
But
You want x squared
now to
minus
solve
11x
for
plus
what
4.
x is, am I right to maybe in one way to make that negative 24 on the other side? No,
No,
don't do that, okay.
no, I see what you're saying to get all the x's on one side, but if it's a quadratic, in other words,
Okay, so
you'll have two answers for x.
I'm going to get past this soon, but okay, before I almost freaking died, that's where I was at the quadratic equation and not getting past that.
Okay.
I've taken some definite brain damage since then, and now I'm finally back here
Cool. Well, welcome back.
to
What,
the quadratic equation.
do you know what I mean by quadratic?
Yeah, it means that it's, well, if I'm going to factor a trinomial, is that gonna be the quadratic equation? Or is,
So briefly, just for being thorough, this is a quadratic equation. Alright, so some number x squared, some number x's, and some number. Okay,
yes, so
that's
we've
all.
been doing that with that structure of trinomials where where there are 3 different kinds of terms.
Uh-huh. A trinomial is an expression that has 3 terms. So a trinomial could be a x to the 9th plus b x to the 3rd plus c. Okay, it has 3 terms as a trinomial.
So
Specifically,
when it's pointed out to me, I'll recognize that
This
is
is a
not
quadratic.
just a trinomial, but that's a quadratic
Yeah,
equation.
it's both, yeah. This is a specific variety of trinomial called a quadratic because of these powers.
It's because of the descending powers and no variable at the end as well, or does that matter? What if that was, what if that last one was cx or 1x or something?
Can't, because then you could combine it into that middle term.
Oh, yes, you still could factor it, yes, but it would still be a quadratic equation even with a totally different variable. And what if there were 2 with exponents? I'm just saying,
So,
if that, okay, same thing is like, if that was bx squared right there, that would no longer be because it doesn't have descending powers? Or would it still be?
okay, bear with me. I'm just trying to wait till you're finished asking your own question, so that's all good. So, in this case, the A and the B and C are numbers. Okay, so like A could be 1, B could be 3, C could be 117. Okay, they're numbers. Okay, so that makes a quadratic. Okay, so a quadratic has 2 answers for x's. Okay, it has 2 answers
Yes.
for x's. Okay, cool. So we're on the same page there. Now,
And that is because there is one
thank you.
that's a
See you
number
Wednesday.
without a variable, I believe.
Yeah, this is a
That's
constant.
important.
Yeah, it's a constant. Like if there was no c, okay, for example, bear with me, we have say 4x squared plus 8, okay? Oh, I'm sorry, plus 8x, okay? So there's no constant right there. Is this a quadratic? That's
Well,
a
no,
question.
and also if it was also
Well-
plus another totally different variable, since it wouldn't be a constant anymore, right? It'd still be an unknown.
This-
And
I hear what you're saying, and your brain is going on and on and on, but you're going down the wrong track. So watch what I'm doing. Is this expression 4x squared plus 8x a quadratic? And it's kind of a
Yes.
trick question, and the answer is yes. And the reason is that there's an implied 0 here for your constant.
oh, that
Important-
wasn't there a second ago, and
Yeah, and it doesn't need to be in order for this to be a quadratic. Okay, so what I'm looking for specifically for a quadratic is x squared. I got an x squared term, I got an x term, and I got a constant. Or an x to 0 term. Okay, if we
Constant
wanna
or
dive
zero.
into it. I got an x squared term, I got an x term, I got 0. But the most important thing that you need for a quadratic is this x squared term.
Okay.
Because I can have a quadratic being x squared minus 49. Okay?
Do I want to factor this though?
Yes. And the reason you want to factor it is because you've got to figure out what values of x will make that 0, make that denominator 0. And that will make that expression undefined. So you're going to take that denominator, you're going to factor it, you're going to set those factors equals to 0. 1 factor, 2 factors equals 0. And then you're going to say, how is this true? What values of x make this true?
Okay.
And the first one, I'm going to call this expression number 1. I'm going to call this number 2. 1 equals to 0 or 2 equals to 0. These are my two values for x. Either this one equals 0 or this one equals 0 to make this whole thing equals to 0.
I'm gonna give it a try.
Okay. More questions? Raise your hand. Okay. Carry on. Plenty of time. I'll be here for a while.
I'm done with this.
Okay. Awesome. Thank you.
Must be trying to factor this wrong though still. I'm having trouble getting something that would be multiples of 24 that are a sum of negative 11.
Multiples of 24 that are sum of 11. So
Negative 11.
negative 11. Cool. So what are your factors of 24? Let's just
3, 6, 12, 24.
3, 6.
12,
What
24.
is
Just making
24
sure I understand
divided
what-
by 3?
6.
Is 3 times 6
I mean,
20?
wait, never mind, not 3.
No, you're right. 3, 6.
8.
Yeah,
So,
there it is, 8.
okay.
And then also 4. 24's got a whole lot of
Yeah.
them, right? It's got 12, and it's got 24.
8 and 4, no. 8 and 3.
And also has a 2, yeah. 2 and 12. 8 and 3.
Negative 8, negative 3.
Say for the people in the back. But you're right.
Oh, God. If I want to know what makes it undefined, do I need to do anything to the top? I'm forgetting a lot of stuff right now that I just learned through both lessons.
It's a great question. Okay, so you have a fraction, you have a thing up here, and you have a thing down here, okay?
All I want to do is make the bottom 0, right?
Yeah, that's
So
it.
leave
So
the
this
top
could
alone.
be, you know, my uncle's horse. It doesn't matter.
Yeah, that's
Whatever.
what I was
My
thinking.
uncle doesn't have a horse, but you know, it could be anything up
Still
there.
what I
and
was
it wouldn't
thinking.
matter. Yeah. It's noise. If you're working on your quiz and you don't know something, you're having trouble with something, call me over and I can take you most of the way there.
I still forgot what I'm gonna do with those two, with that set. Am I just gonna take the numbers that were left out of it? Am I
Well,
gonna distribute?
Remember here, you've factored it into a binomial and a binomial,
Is it -3 or -8 now?
and you're gonna figure out what values of x make that.
Oh, it's gonna be one of them.
It's gonna be this one or that one. There are two values of x that will make that undefined. Okay, either one of them will turn that whole expression equal to 0.
Okay, so -3, comma, -8.
Yeah, that's it. Do you understand it?
Well, I mean, I did a second ago when I just said that.
Well,
but
no.
I'm gonna forget something on the next
Check it.
one.
You've got one of your answers is -3. Okay, if you plug in a -3,
I can make those values be x and it should be right. I can check it.
what happens? Yeah, try it. If you plug in a -3, you'll find that that
Um,
denominator turns to 0, and that's
Is
what
a
you want to know.
negative to the power of 2 a negative or a positive? So is that negative? That's 9, right? -3 times -3 is 9. Okay.
Sorry, thank you, sorry.
Hmm.
Yep, cool. All right, so you will be able to factor, and you will factor. So this is right. What you've done here, on the bottom, there's an opposite. And the opposite, a minus 2 and 2 minus is. Those are opposites of each other. And when you divide opposites, they turn into that negative. So they go away, they cancel out, and you're left with minus 1 and 4 minus 3. So that's your answer, minus 4. So on this one, you're gonna factor it the same way. You pull out what you can. I would say that your factorization here is not quite right. In other words, 28, if you pull out a 7, it's not. You're close. Yeah, and it's a minus 1. Yeah. Okay, so on the bottom, you can pull out a 3 from both of those. Right, so pull out a 3. So not quite, but, so on the bottom there, if you pull out a 12 in your first term, that will leave you with 1, but you can't pull out a 12 from a 3. The biggest thing you can pull out from that denominator is just 3. I'm gonna write it, because I don't wanna write it on your paper here. So my denominator is 12 minus 3k, right? Did I remember it right?
Yeah.
Yeah, okay, so I need to factor something out of this. So what is the biggest thing that I can harvest from each one of these, that I can pull out? What is the biggest thing that they have in common? The biggest thing that they have in common is a 3. I can't pull out more than a 3 here. I can definitely pull out a 3 here. So the reason that this is a little bit confusing is because normally this would look like this. We usually write the variables first, right? This is the same. If it was written this way, can you see how you pull a 3 here and a 3 here?
I just burnt myself trying to check that. Okay.
Take a break, come back. We'll be here for another hour, so you're all good. All right, here's another way I'm gonna write this. I'm gonna factor this guy into 3 times 4. That's what I've got
Still
here. And this guy, I'm gonna factor